In this video we're going to explore some logging options in the Go programming language, and in particular we're going to look at a package called slog. And slog was introduced very recently in Go version 1.21, and this is a package for structured logging in Go. Now, structured logging is useful because it outputs logs in a format that allows them to be searched and allows you to find the particular pieces of information that you need to find. And the slog package offers functionality in Go for things like log levels, contextual logging, and different handler formats, for example JSON handlers, and it also provides tools to build child loggers and also redact sensitive information. We're going to dive in this video and see examples of all of these, so let's get started. Now this is the package here, it's called slog, and there'll be links to these packages below the video. What we're going to do to start with is look at the standard log package that was built into Go since the beginning of the programming language. And if we look at the overview, the package log, it implements a very simple logging package. It defines a type called logger with methods for formatting output. And this package provides functions like printf and printline, as well as similar functions called fatal and panic that do slightly different things and exit the program when they are called. Now let's start with a look at the log package. I'm going to open VS Code where I have a very simple Go application. It consists of one file called main.go, and we've defined a package called main here. What I'm going to do is add a statement to log.println so we can see what kind of output this generates. And let's say we've submitted an order and we want to output that statement to the terminal when this particular program is run. Now I have a terminal on the right hand side, and I'm going to run the go run main.go command, and that's going to output that log in the format that is generated by default by the log package. And you can see that format here. It consists of the time at which this log was generated, as well as the message that was passed into the println function here. So that's the very simple use of the log package. What we can do is customize the default output slightly. Now what I'm going to do in order to do that is create a variable called logger, and we're going to call a method from the log package, and that's the default method. Now what does the default method do? Let me get access to the IntelliSense here. Default returns the standard logger that's used by the package level output functions. And once we get access to that logger, we can call a method on that called setOutput. And what this can do is it takes an io.Writer instance, and it's going to send the output to that writer. Now the io.Writer is actually an interface, and there's many implementations of that interface in Go. And one of these, just a very simple one, is the os.standarderror output. So what we're doing in this program is we're getting access to the default logger and we're setting the output to standard error. And this can take any writer. For example, it can take a file, and you could then send your log output to that file. So what we're going to do is just call a method called println, and again I'm going to pass that string order submitted, and on the right hand side we'll run this application and we're going to see that we get that output, and that's coming to standard error, and it's the same output with obviously a different timestamp. And there's one more function to show from the log package, and that's the log.new function. And what this function does is it allows you to create a new logger, and it takes three parameters, the first one being the output, which is an instance of io.Writer, as well as a prefix, which we'll see in a second, and some flags can be sent as well. What we're going to do now is we're going to implement this function, and we need to pass a writer. Again, I'm going to pass standard error, and let me move this to a new line so we can see it more clearly, and I'm going to remove the previous statement. As well as that, we need a prefix, so let's say this is for an orders application. We can prefix the output for this logger with this prefix here. And then finally we can pass some flags. Now these are constants that are defined in the log package. For example, one of them is log.LDate, and we can separate the flags with this pipe operator, and we can pass a bunch of other ones in there. And if we save that after adding those flags and run the application on the right hand side, you can see we get the same output as before, except that now we have a prefix of orders, which is the prefix we specified as the second parameter here. And we can add extra flags here. For example, I could add a call, or rather a reference to log.L short file, and what that's going to do is actually add the file in shorthand format to this output, so you can see that we get main.go, and we also get line 14 here. And you can see that a little bit better now. And line 14 is this one here, the logger.println function that generates that output. So this is all working fine. We have a log package in Go. So why do we need structured logging? Now there are some problems with the log package as we see it here. We don't have the concept of levels built into this package. We're also unable to easily generate structured JSON output or log format output in key value pairs. What we actually get as output here is just a bit of text. It's a string containing the flags that we set and the message that we passed in, but we can't use any kind of structured key value lookups here because it's just a dump of text essentially. And finally, we also have limited configuration available in this log package. So in order to customize the log output, we can now use this new package called slog. So what I'm going to do is remove all of this code that we have here, and I'm going to save this file, and that will remove the imports at the top. Now you need to have Go version 1.21 installed. If you run the Go version command, you'll get the particular version that you have, and you can see that I'm on 1.21.4. And if you have that, what you can do is call functions from the slog package, for example slog.Debug, and we can pass messages in there, for example debug message. And I'm going to define a couple of extra methods here to show that we have the concept of log levels built into slog. So we have slog.Debug, slog.Info, and let's again use order submitted as a message. And I'm going to copy that down below, and we can also use slog.Error. This is another level function. And I'm going to change the message here to error occurred. And I'm now going to run this program, and so we can see the output better, I'm going to close this terminal, and I'm going to open a new terminal and bring that onto the screen now. I'm in the same directory as that main.go file, as you can see here. We can run that again with the go run command, and we're going to see the output from these log messages. And you can see we get the time of the logging as before, as well as the log level here, info and error, and the message that was passed to those methods. Now one thing you might notice is that we don't get the message for the slog.debug call, and that's because by default the default log level in the slog package is set to info, and any message with a lower severity than info will not be shown by default. What I'm going to do is define a variable called logger as we did before, but this time what I'm going to do is call the slog.new function. And this creates a new logger with the given non-nil handler, and that takes an instance of the slog.handler. This is another interface that's built into the slog package, and what we can provide to that is one of the two handlers that are built into the slog package. I'm going to use the new text handler, and what this does is it creates a text handler that writes to the writer that we provide as a parameter, and we can also specify some options as well. And this handler is going to output our logs in key value pairs, as we're going to see in a second. So let's pass an instance of the io.Writer interface, and that's os.standard_error. And right now I'm going to pass nil for these options. We're not going to specify any custom options at the moment. So we now have a logger instance here, and in order to use that logger by default, the slog package has a method called setDefault, and we can pass that logger instance into that method, and it's going to make it the default logger as it says here. Once we've done that, anytime we call these methods like debug, info and error, it's going to use that logger that we passed in here to the setDefault function, and that is going to then output our logs using this new text handler. So let's see another example of that. If we go back to the terminal here and run this command, what we're going to get is a different format, and you can see we have keys, for example time, and values here for each of the keys. So the keys are time, level and message by default. So we can see the time at which the log was generated, we can see the level, and we can also see the message. And because these have keys, that makes it a lot easier to do lookups for these values and extract the information that you need. And if you're wondering about this output format, I'm going to reference this page here, and this is the name given to that format, and this has been popularized by Heroku. And as it says, each line consists of a single level of key value pairs that are densely packed together. So that's the format for this particular handler, the new text handler, but we can add another handler, and the slog package has two handlers built in. The other one is the new JSON handler. And as the name implies, that's going to output these logs in JSON format. When we rerun this program, you can see we now get that output. So we're now getting JSON output for our logs, and again, if you take these outputs and you look up each record by its timestamp or the level, you can then extract the data that you might need in order to find things that are going on in your application, and also to build things like dashboards and charts around that data. And that is of course where centralizing your logs on a platform like BetterStack is going to pay off dividends. It allows you to analyze those things much more clearly, and we are aided in the case of Go by the use of this slog package. So two different output formats here, but they are both structured formats with key value pairs. Let's now move on. What I'm going to do is show how we can actually get access to this slog.debug output. And in order to do that, we can pass some options to the handler that we're passing into the slog.new function. So rather than passing nil, we're going to pass a second argument here, which has to be an instance of, or rather a pointer to, an slog.handler options. So what I'm going to do is I'm going to define this variable in a second, but it's going to be called handler options, and I'm going to copy the name of that, and on the line above this logger we're going to define that, and that's going to be a pointer to these handler options. So slog.handler options, and we can pass in an option here called level, and we're going to set that equal to the slog.level debug. So these handler options are setting a level of debug, and when we pass that into our JSON handler, it's going to tell the logger that we have that we want to output messages of debug level and above. So we can save that and then go back to the terminal, and I'm going to rerun this command, and I'm getting this error here, and that's because I didn't close the options, or rather I didn't add a comma at the end here. So what we can do is rerun this again, and we're going to get the output, but this time we get the output for the debug message as well. Now we can add another option to these handler options. For example, let's add one called add source and set that to true. If we go back and run this again, what we're going to see is we get an extra key in the output called source, and that links to some particular information about where the log was generated, and it was generated in the main function in this particular file. So that's another option you can pass to these handler options. I'm actually going to remove that. We're going to keep the level debug for now, but we can remove that extra option. And let's now move on. What we're going to see is how we can log out our own attributes, so custom key value pairs that we want to be in the log output. And of course this is very important because the default logs, they are giving us some useful information. For example, let me clean this up and rerun this. If we look at this, we get the level, which we need to know. We also get the message, which is very important, and the timestamp. But we might want extra key value pairs giving more contextual information about the log that's been generated. For example, we might need a trace ID, a request ID, or user ID, or some kind of information like that to try and narrow down which particular user or request or methods are actually generating this output. So we can add our own custom key value pairs to the output that we are generating from these slog methods, and we can do that just by passing extra keys and values to the methods. Actually, for now I'm going to remove the slog.debug. Let's use slog.info, and I'm going to pass extra key value pairs, and this is done in a couple of different ways. We're going to see this example now. What we can do is we can pass a key, and we can call that anything we want. Let's call it user, and we're going to give this a value of John Doe. So what we're telling the slog.info method here is that we want to pass this extra key called user, and we're passing a value here of John Doe for that key. And of course in a real system this value is probably going to be some kind of dynamic value for the user. But let's save this, and we're going to go back to the terminal here. I'm going to clear this out, and we're going to rerun the script, and we're going to see this output that's generated. We can see we get the extra key for our context here, our user, and the value of John Doe. And we can pass as many key value pairs as we want to these methods such as info and error. So for example, if I also wanted to log out the user's ID, I could add another key called ID, and you're seeing the error here that we're getting because we don't have an even number of arguments after the message. You need to make sure every key has a value if you're going to use this structure, and this has caused a bit of debate in the Go community, I believe. But anyway, we do need to add a value here, so let's use a value. This time I'm going to use a value from the random module. Let's call a function called int n, and the int n function here is going to return an integer between 0 and the number that we pass in. So let's pass in 50, and that's going to give us back a random integer between 0 and 50. If we go back to our terminal and run this again, you can see we now get this ID at the end here, and it's set to value 49. If we rerun it again, we get 39. So we get a different ID each time we run the program. And what we can do, if you don't like this format where you have a key, then a value, then another key, then another value, is you can consolidate these into slog attributes. So an attribute is just a key value pair. What I'm going to do is start with the user. What we can do is define an slog.string attribute, and you can see that takes a key and a value, and it returns one of these attributes. So the key was user, and the value is going to be John Doe. And what I'm going to do is move these to a new line. So let me clean this up a little bit. We're going to move these to new lines so we can see it clearly. And the second slog attribute that we want to add here is for the ID. So let's remove that. And this time we're going to use slog.int. And the key was the ID, and the value, again, let's use the random package, and we're going to use the int_n function and pass 50. Now if we save this and go back to our terminal, I'm going to clear this out and run the application again. And again, we've got a missing comma, so that's my mistake. Let's add that to the slog.info call and go back and rerun this again. We're going to get the output now, and it contains the ID and the username as before. So this is a different way of adding these attributes. Rather than a key and a value, and then another key and another value and so on, you can actually consolidate them into slog attributes and pass them into the function. And whichever one you prefer, that's just a matter of personal preference. You can use whichever one you like best. With this method, you get the benefit of strong typing, but other than that, it's pretty much the same thing. So we've seen a few things so far. We've seen how to define different handlers, including the JSON handler and the text handler that's built into the slog package. We've seen how to override the default logger and set it to a custom one that we've created. And we've also seen how we can pass in some handler options when we create these handlers in order to customize things like the log level. And of course, we've just seen how to pass custom arguments, custom key values to our slog level methods. Let's now move on. What we're going to do is we're going to see how to use groups in the slog package in order to group together contextual attributes. So let's say for this example that we want to log out data on users, but we also want to log out some request data, for example, whether it's a post or a GET request. And we want to very commonly add this data to our logs. Now what I'm going to do to start with is I'm going to remove these attributes that we passed to slog.info. And what we're going to do above that is create an slog group. And we're actually going to create two of these. I'm going to call the first one the user group, and that's going to be an slog.Group call. And you can see that the first argument to this is a key, and that's the name that we give to this group. I'm going to give it a name of users. After we give the group a name, we can pass a variable number of arguments here. And this takes the same format that we saw before, where we have a key, then a value, then optionally another key and another value. And these are grouped together into this slog group. So let's see an example of that now. Again, we have a user ID, which is going to be equal to the rand.int_n function, and we'll pass 50 into that again. And let's also pass the username of John Doe into this function. So I've cleaned this up a bit. We have the name of the group on the first line, and then we have each key value that we want to add to the group on each line below. So the ID and the username, these make up the actual key values that we want to add to this group. And then we can pass the group to our slog level methods. So let's pass the user group to slog.info. And I'm also going to create a second group here, and we'll call that request group. And we're going to make that equal to another slog group. We'll give this one a name of request. And for this group, I'm only going to add one single key and obviously a value for that. So let's just say for this imaginary request, the method is a GET request. So let's copy the name of this group and add it to the call to slog.info. So we're actually passing two groups to the slog.info method. And if we scroll up a little bit, we have a JSON handler. Let's see how the JSON handler outputs the data for these groups. I'm going to run the application and we get this output here. Now what I've done is I've copied that and I've pasted it into VS Code and formatted it so we can see this better. What we have are the typical keys here for the time, the level and the message, but we've added the groups for the users and the request to this application. And I'm going to split screen this so we can compare it to the code. What we have is a group, the user group here with the key of users, and that's the key that's added to the output JSON. And with JSON, the user group here is represented as a nested object. And each key and value corresponds to what we have in the group itself. And that is exactly the same for the request group. We have a group with the name or the key of request. And then we have a single key and value in that group. And that's for the method. And that's added as that nested object. And we're going to see how this output changes when we use the other handler that's built into the slog package. And that's the new text handler. If we save that and go back to the terminal, I'm going to run this again. And remember, the text handler outputted that key equals value format. You can see the nested data here at the right hand side of this output. And we have the key of the group and then a dot syntax and then the name of the actual nested key within the group. in this case the ID, and also one for the username. And we have the same for the request group here. That group has the key name request, and then we have the method attribute within that group. So that's represented in this key value output, with the nested data separated using this dot notation. So that is an example of how we can use these groups in the slog package. We define an slog.Group, and then we can add any number of keys and values to that group, and we can then pass the groups into our log level methods such as info and error in order for all of the keys and values in that group to be present in the output. Let's now move on. We're going to look at the concept of child loggers. Now, often when you are logging data, you want to log the same keys and values many times and at different places in your application. There are different ways of adding those keys and values. You could add them to every single call of methods like slog.info or slog.error. But that is not the most maintainable approach, because anytime you wanted to change any data that's present in those logs, you would need to add new keys and values or remove keys and values from every single instance of these calls where you've added those particular attributes. Now, there is a better way to do this in Go. What we can do with the slog package is we can define a child logger and consolidate a set of attributes in that child logger. So basically you can add the keys and values you want to repeatedly appear in your output in a single place, and then if you need to change things later on, you simply change that child logger definition, and that will then apply those changes to anywhere that you're using that particular child logger. So let's see an example of that now. We can use a method that's defined on the logger object, and that's the with method. And this will return a new logger that includes the given arguments converted to attributes, and then these attributes will be added to every single output for that logger. So let's go back to VS Code here, and what I'm going to do for this example is I'm going to remove the user group. We don't need that anymore. We'll keep the request group around, and we're going to create an slog child logger for the data that we have in this request. So I'm going to save the file. We have this group here called request group. What I'm going to do is I'm going to call that with method that's defined on our logger. So we're going to use the logger here, and we're going to say logger.with, and that will, as it said in the docs, return a new slog logger object. And in order to add all of the keys and values from a group to the logger by default, we can just pass the name of the group that we've already defined into this method here. Now, as the doc said, this will return a new logger. So what we're going to do is create a variable called request logger, and whenever we use this request logger in our program, it's going to include all of the attributes from the group that we've passed into this with method by default. So what we can do is we can change these methods here. Rather than slog.info, we can use our request logger that we've created, and we can do that for the error as well. And I can remove this group that we're passing into the method, because that's now going to be done through this child logger that we're using to call these methods. So let's now save this file, and we're going to go back to the terminal here, and I'm going to clear this and run go run main.go. And you can see in the output here that we get the request method added to both of the outputs that we have in this application. So if we go back to VS Code, we have a call to .info and .error on the logger, but because we've created this child logger that has the request attributes added to it, every time we call a log method using this logger, it's going to add the request to the output, as you can see here. And this will work for any number of attributes in the request. So if I added another one, for example, let's say just add one called content type here, and we set that equal to application/JSON. We've added another key and value to the request group, and we're passing that into the with method, which will create this child logger. So when we run this application again, we're going to get that extra request value for the content type added to the logs. So this method of creating a child logger is a good way to consolidate keys and values that you want to add to multiple places in your application. You can simply create a child instance of the logger and then call the normal methods, and then that will by default add those keys and values to all of your log output. And of course, as well as passing a group, you can actually pass keys and values into the with method. So if I cut these values out of the group and we pass them into logger.with, this time, as well as the group, we're passing content type and application JSON. If we save this and go back to the terminal here, I'm going to execute this one more time, and we're going to see that we get almost the same output, but because this is no longer part of a group, we don't get the prefix with the group's name. But the key point again is that we can add any number of keys and values, including the keys and values from a group, into a child logger, which will then add those keys and values to all of your outputs. Let's now move on to another example. We're going to see how to log out to files in a Go application using the slog package. So I'm going to scroll up here and we're going to look at this handler that we have, and to this handler we passed the io.Writer instance, and in this case it was standard error that we passed in. Now we can pass anything we want into this function that implements the io.Writer interface, and that basically means anything that defines a write method can be passed in as the first argument to our handler here. So let's start by working through an example. What I'm going to do in the terminal is I'm going to define an environment variable. So let's clear out what we have, and I'm going to reference env, and then we'll define a variable called LogFile, and I'm going to set that equal to a variable, or a value, sorry, called app.log. And what this does is it sets an environment variable for the duration of this PowerShell session in this case. And if you want to do the same on a Unix system or on a Mac, you can use this command. It's called export, and then you can define your variable log file and set it to the value that you want. So once we've defined that environment variable, what we're going to do is we're going to read it into our Go application. So let's open up the file main.go, and we're going to read it in at the top of the main function. So let's set a variable called LogFile, and we're going to set that equal to the os.getEnv function. And getEnv will retrieve the value of an environment variable named by the key that we pass in, and the key that we used was LogFile. And I need to make sure as well that I'm assigning that value correctly using that syntax here. So what we're doing is we are reading the log file from the environment, which is a common practice. And what we're going to do is open this file in the application, and we're going to use that file as the io.Writer that we're passing into the handler. So I'm going to open a file in this application using the os.openFile function. And this takes three parameters that we're going to use. First of all, the name of the file, and we're going to pass that log file that we read in from the environment as that parameter. And we then need to pass in a flag to this method. So I'm going to pass in a couple of these. We're going to use the os.oCreate flag. So that's the first flag. Let's use another one now, and we're going to tell the openFile function that we want to write only to this file using this flag here. It's called write only. And the final thing we want to say, because this is a log file, when we actually write things to the file, we don't want to overwrite what's already there. So what we're going to do is we're going to pass the o_append flag. So that's the three that I want to pass in, and the final parameter is the permission, and that is going to be 0666. And this mode allows the file to be read and also written to. Now the openFile method returns two things. It returns a pointer to a file and also potentially an error. So we need to get those at the start of this statement. So let's create a variable called file, and we'll also get the error here when we call os.openFile. So what this is doing is it's going to open that log file. If it doesn't already exist, it's going to create it using this flag. And it's also specifying that we only want to write to the file with this flag, and also that we want to append any output to the file. Now when we potentially get that error back, we need to check if the error is not equal to nil. And if it turns out we've got an error, what we can just do in this case is panic and pass the error through to the panic function, and that's going to exit the application if there was any problems opening that file. Otherwise we can move on, and what we always need to do when we open a file is defer the file.close method. And when you defer a statement in Go, it means that when the function returns, the statement here will be executed, and in this case it's going to close the file, and that's going to prevent any potential memory leaks. So this gives us a file object, and this is an implementation of io.Writer. So we can actually pass it into our handler here. Instead of os.standard_error, let's pass in the file itself. Now once we've done that, I'm going to bring up the terminal and I'm going to run this command go run main.go, and this time you see that we don't get any output on the terminal. If we go back to VS Code and open up the file browser on the left hand side, we now have this file called app.log, and that's the name that we gave to the file in the environment variable. And we're getting this output here in the key value format, and we get all of the keys and values output to this file. So now we've changed the structure of our output. We're no longer logging to the terminal to standard out or standard error. This time we're logging out to a file, and we do that by passing the file into our handler, and this will work for the JSON handler as well. So if we change the name of the handler and run this again, if we go back to the log file, this time we get the logs coming out in JSON format. So it's very easy to change the way this works to log out to a file, and you might actually want to log out to multiple destinations. Let's see an example of where we can write not only to the file but also to standard error. And to do that, we're going to use a utility from the io module, and it's the 𝗵𝗽𝑊riter. This will create a writer that duplicates its rights to all of the provided writers, similar to the Unix T command if you're familiar with that. And each write is written one at a time to the writer. So it's very easy to implement this. What we can do is go back to VS Code, and just after we defer closing the file, we're going to create a variable called W, and we're going to set that to io.MultiWriter. And let's look at the signature for this. This takes a variadic number of writers. So we can pass as many writers in as parameters as we want. So let's start with os.standard_error, and then we can also pass the file that we created as the second writer. So we now have W. Let's pass that instead of the file to the JSON handler, and we can then save this Go file and go back to the terminal. This time we expect to see the JSON on the terminal, and you can see we get that back here. But if we go back to the program and go to app.log, that JSON is also being sent to this file as well. So we're now writing the output of our logs to multiple destinations. Very easy to do that by just implementing a 𝗵𝗽𝑊riter and passing every destination that we need as parameters to that 𝗵𝗽𝑊riter. Now the last thing I want to do in this video is show how we might want to redact sensitive data from our logs. And sensitive data could mean credit card information, it could mean private user information like passwords and email addresses and addresses themselves. You don't want to output stuff like that in your logs where it could potentially be read by people that shouldn't be reading that information, so you want to redact that information. We can do that by implementing an interface called LogValuer in Go. So let's go to the documentation and look at this type. It's called LogValuer, and this is any Go value that can convert itself into a value for logging. So the idea is we take a value in Go that we want to log out, but we want to perform some kind of transformation of that value so that it's safe to log in our output. And this interface, LogValuer, will allow you to specify how your custom types should be logged. We're going to see an example of that now by going back to VS Code. And just above the main function, I'm going to define a type that we're going to call user, and this is going to be a struct. And it's going to contain a few fields. Let's start with the ID, which should be an integer, and in JSON we want to output that with the key name of lowercase id. We also want this user to have a username, and that's going to be a string, and again in JSON we want that to be equal to a key called username. And the final field is going to be the password, and that's going to be a string as well, and in JSON we want that to be the password. Now you could omit this from the outputted JSON just by converting the member to lowercase, but let's assume that we don't have that. We're going to use the LogValuer interface in order to change the output for this particular type, the user type. So what we're going to do is we're going to go down to the very bottom here, and just after we define this request logger, what I'm going to do is create a variable called user, and this is going to be a pointer to a user object. So we're going to pass three values: the user's ID, which is going to be another instance of a random integer between 0 and 50. We also have the username. Let's just pass John Doe, and the password for this user is just going to be secret. And I'm going to remove the call to the error method, and we're just going to pass the user in to the request logger.info method. Now that's the value of the user. We also need to pass the key, which we're going to pass here as user. So basically the key is user and the value is the value of this struct. So we're going to see that represented in the output. Let's go back to the terminal and run the application. And we get this output. Again, I've pasted that into VS Code so we can see it better. By adding a key called user that points to that structure, you can see we get a nested object in the JSON data with the ID, the username, and the password. Now of course the problem here is that we have a raw string password appearing in our log output. That is not desirable. Under no circumstances do you want to do this. So what we're going to do is we're going to implement that LogValuer interface in order to define our output representation for a user. Now it's very easy to do this. If we go back to main.go, I'm going to go above this main function and just below where we define the user struct, and I'm going to define what's called a pointer receiver method. And let's see exactly how to do that just now. We define a function, but before we actually define the name of that function, we are going to pass a pointer to the user struct. And then in order to implement the LogValuer interface, we define the method called LogValue, and that's not going to take any parameters, but it's going to return an slog.Value. So this syntax is defining a function that will operate on an instance of our user structure. And in order to customize the log output for the user, we just need to define this function and use that pointer to the user object. What we return from this function is what we actually want to be output when we log out an instance of the structure. So let's log out the slog.int value. So we're going to return an integer when we log out this user, and we just want to log out the user's ID. So we have access to the struct that we're working with through the variable u that we have in this pointer receiver here, and that has the field name of ID, and that's what we're referencing and returning from this LogValue function. So that's the only change we actually need to make. Let's go back to the terminal, and what we hope to see is that when we log out the user, rather than getting this entire object of data, we are now going to get just the user's ID. And this is the output we get. Again, I'm going to copy that to VS Code. So let's go back to VS Code, and you can see this time we only get the user ID in the output. So if you need to customize the output for a particular type that you have, or if you need to redact some data, you can implement the LogValuer interface on your particular type, and then return whatever value you want to come out in the logs for that particular type. And we could do something more complicated here. So for example, we could use the slog.StringValue function and then use the format.sprintf. And the sprintf method allows us to pass some kind of format string here. So we could pass the string here user ID and then use the %d, and that will give us the value for the user ID, and then we could pass more information in this string. For example, we could pass for user and then pass the %s in here, and what we're going to reference is the user's ID and also the username here. And these are both fields on the structure, and we are referencing them in the sprintf function. And this is telling the slog package that when we encounter this type, this is the particular format of the output we want to generate. So let's test this out, and we're going to run the program. And you can see the output we get here for the user key, user ID 40 for user John Doe. So that has changed again the output format just by implementing the LogValuer interface. So that's all for this video. We've showed numerous features of the slog package. Of course, there's much more you can do with slog. For example, you could send your logs to a service like BetterStack in order to better aggregate and analyze those logs and search through the logs for useful information. You could also look at how to work with context when you're using these loggers, and also you can look at third-party handlers rather than defining or rather than implementing the two handlers that we have in the slog package, which is the new JSON handler and the new text handler. You can also integrate with third-party loggers, and there are many options for that. We'll link an article in the description of this video that shows you a comparison of many different log packages in Go. If you're interested in more Go content or more logging content in the Go programming language, let us know in the comments. If you have any thoughts, please share them in the comments as well. Thanks again for watching. If you've enjoyed this content, please consider subscribing to the BetterStack YouTube channel. Thanks again, and we'll see you in the next video.